Check, check, here we go. Welcome back, physics fans, doing the traffic light story. So, let's say, what minimum distance is required to accelerate the car from rest to the posted speed limit? So the initial speed is 0. The posted speed limit is 17, and the acceleration here is 5. So they're asking the distance that it takes and the time that it takes. Okay, so what formula would you use? The distance formula without time, you would probably use VF squared equals VI squared plus 2AD. So 17 squared is equal to 0 squared plus 2 times 5 times D. So the 2 times 5 is 10. So this is going to be 17 squared divided by 10 is the D. Okay, so 17 squared divided by the 10. So the starting distance to get up to speed takes him 28.9 meters. How long does it take for that? Okay, so we can just, the time is going to be the change in velocity over acceleration. I get that from the acceleration is the change in velocity over time and just rearrange it. So the change in velocity is 17 over 5, and that's going to be 2.4 seconds. No, 3.4. 17 divided by 5. Now, when you're stopping at this stage 2, what's the distance to stop? Different numbers. VI is 17. VF is 0. Just swap because you're going from maximum speed down to 0. And the acceleration here is negative 8. So it'll be the same formulas, just different numbers. So VF squared equals VI squared plus 2AD. VF is 0. VI is 17 plus 2 times negative 8D. So this is going to be 17 squared divided by 16, not 10. So 17 squared divided by 16. So it took 18.0625. I'll just write it all down. Don't know if I want to. I'll do it in blue for slowing down. And the time is the change in velocity over the acceleration. And that's going to be 17 over negative 8. But the change in velocity is also negative because it decreases, so the negatives cancel, so we will get the positive time. 17 divided by 8, which would be 2.125, 2 and 1/8. 2.125 in blue, because that's the deceleration. That's part 2. Okay, so this was part 1. This was part 3, actually. Part 3. No, part 2. I said I claimed it to be part 2. But over here, part 2 of the deceleration, and the constant speed in between. If the traffic lights are 200 meters apart, what distance do you travel at the 17 meters per second? So your velocity is 17 meters per second for that whole distance. That whole distance is 300 meters minus the 28.9 and minus the 18.0625. Minus those two distances, because it's 300 meters from stoplight to stoplight. There's an acceleration time, that's 28 meters. There's a deceleration time of 18 meters. So the rest of the distance is this. So we take 300 minus that number minus that number, and we get 253.0375. I'm just keeping in a stupid amount of sig figs. And how much time will require? Because this is constant velocity, time is just distance over velocity. So the distance is that number there, and divided by 17. So take this number that we have and divide it by 17. That's the time for the constant velocity part. 14.8846 seconds. I'll just keep it down to a stupid amount of 6 sig figs. So that's the time. Now, so question D says, based on your previous answers, what would be the shortest legal time in seconds for the driver to go from one stoplight to another? Okay, so it's the time of section 1 plus the time of section 2 plus the time of section 3. Okay, 1 is 3.4, and this is 2.125, and plus, that's our third one, is equal to, so take that plus those other two numbers, 3.4 plus 2.125, and that's 20.41. We'll just bring it down to 4 sig figs. 20.41 seconds. Okay, that's it. So when how many steps was this? 1, 2, 3, 4, 5, 6, 7. So that's why on the Moodle, I say it's out of 14 marks, 2 marks for each one, and then do the same question again, different numbers, and do it all in one. So basically, you figure out individual steps. This one asks each question along the way. What's this number? What's this number? What's this number? This number, this number, and then it tells you later on if they're right. And then the second one is, here's the question, give me the final answer. So you get to do it twice. And that's how you do it. Online, I don't ask this question, but here it is. What order of the following displacement time or distance time graphs would you correctly put together as a pictorial representation of this problem? So initially, you're at rest. What does rest on a distance time graph look like? It looks like B. This is your distance time graph. You're sitting still. And then the light turns green and you take off. What does acceleration look like? It looks like C. So far we got B and then C. What does constant velocity look like? It will look like A. That's constant velocity. The slope doesn't change. So there's B and then C and then A. And then what does slowing down look like? D. E is what slowing down looks like. D is actually moving backwards. D is going down. So at no point does D ever occur here because when you're going from traffic light to traffic light, unless you're driving on a standard uphill, you don't go backwards. So D doesn't actually exist. You'll slow down and come to a stop. And then you go at rest again. So this is E, and then back to B. So B, C, A, E, B. Your distance time graph looks like that. Let's just get it in big red. Where is it curved? It's only curved here, and it's only curved there. Okay, B is a straight line beforehand. So it's only curves in those yellow areas that I highlighted. That's the point where there was acceleration, and that's what we calculated. A is constant velocity. B is also constant, but it's constant at rest. A is constant at 17 in this question. That's it. That's how you do the traffic light. Okay? Here's a simple one. Figure out what A is and T is. And then on the back, let's do a quick question here. Given the position time, velocity time, and acceleration time graphs, I can't really read that. Can you read that on yours? Did it print out better? No? Okay. We'll call this 3 meters per second. It starts off at 2 and 14 seconds. So it's 2 and 14 all in every graph. You started at a distance of 4 and an initial speed of 5. Okay? How would you do this question? Well, let me just stop this